in this example over here, we're given a function f over a domain of a to infinity, with a coordinate r, well, I guess for all of the functions we've dealt with so far, and it has the rule of 2x squared minus 4x minus 3. So what we want to try to do here is restrict the domain of f so that its inverse function f of -1 exists, and fully define this inverse function in function notation. So to do this, the main aim over here is to make our function f a one-to-one function, because remember that if you were to get the inverse of any particular relation or function, its correspondence is going to swap with one another, and so if you get the inverse of a one-to-one function, you're going to get a one-to-one again, and the vertical line test will pass again, thus the inverse being a function. So what do we need to do here? We recognize this is a parabola, and this parabola, if you're trying to make a parabola a one-to-one function with the maximum domain, then what you want to do is restrict this at the turning point. So if you want to find the turning point, and you're given our function in polynomial form, you might just want to use the axis of symmetry. So recall that the axis of symmetry is that x is equal to -b, so we have -4, well, sorry, negative of -4 over 2a, where a is 2. So we have 2 times 2 to the bottom. This will give us a value of 4 over 4, so x is equal to 1 at our turning point. So to find out the coordinate of the turning point, simply sub this back in, so that we get 2 minus 4 minus 3, so we're going to get -5. So we know our turning point is at 1, -5. Okay. This part over here probably isn't that important. The real important one over here is the 1, and we're going to graph it out just to see why. So just on the side over here, it's a really quick sketch. We're going to have a turning point at 1, -5. We know this is a positive parabola because the coefficient of x squared is positive. Something like this. Okay, so we know that we need to restrict, well, the function from the beginning was from a to infinity. So in this case over here, we want the right half of the parabola, since we don't want to go to negative infinity. If you go to negative infinity, then we're going to be taking the left half over here. So we want to have this turning point and nothing on the left side of the parabola. That's all going to be restricted away, so that we get a one-to-one function over here. Okay, so for starters, we know that x must be restricted to 1 to infinity. Okay, so what's next? So over here, if we want to fully define the inverse function, we need to find the rule. So to find the rule of f of -1, we need to swap the x values and turn them into y, the y value over here into x. So just put it over here. X is equal to 2y squared minus 4y minus 3. Okay, gonna need a bit of space here, so I'll just draw a line. If you want to solve for y over here, simplest way would be to complete the square. Remember that we need a coefficient of 1 over here in front of the y square. Okay, so that'll be the first step. Second step is to halve the coefficient of the linear term here, -2y. So half of -2 is -1. So x is equal to 2 of y minus 1. Negative 1 is half of negative 2. Square this. Remember that we added negative 1 squared inside this whole factorized term, so we need to subtract by negative 1 squared, which is 1 of course, minus 3 on 2. Okay, just work up here now. So we can easily move everything over to the other side to make y by itself. So what we're going to do is, we're going to divide both sides by 2 and add both the 1 and 3 on 2. So we're going to get x on 2 plus 1 plus 3 on 2 means plus 5 on 2. It's all equal to y minus 1 squared. Okay, so once you have that, you need to square root both sides. So when you square root both sides, remember to take the positive and negative solutions. So we can get plus or minus, I'm going to factorize the half out, half x plus 5, and we'll take the 1 over while we're at it. This is all equal to y. Okay, so y is equal to this third-like expression over here. So we take both the plus or minus solutions. Well, both of these fit into the domain of the original function. Now remember that the domain of the original is the range of the new function over here. So our range has to be from 1 over here to infinity. Now for that to happen, would you expect to have a positive square root or a negative square root? Well, the positive one, right? It's the one that goes up from the turn point, or the end point of our surd function, rather. So we're only going to take the positive square root, and if we fully define our function, our inverse function, we say that the inverse of f has a domain of 1 to infinity. Sorry. Negative 5 to infinity. Over all real numbers. And its rule is positive square root half x plus 5 plus 1. Okay. So function notation, write the name of the function first, its domain. It will generally be over a codomain of all real numbers, and then the rule can be expressed like so.